So good morning and welcome CPP India. I'm Ankur Satle. I'm a C++ evangelist and enthusiast in Pune and very happy to be associated with this C++ community. CPP India aims to bring together the Indian community to facilitate sharing, learning and expansion of their C++ knowledge. It's a platform to discuss, share, showcase your C++ work, seek and provide guidance for C++ focused topics. Please join us at cppindia.co.in at the join us link there. You can interact with the community on via our Discord server. Follow us on LinkedIn, Twitter, Facebook. You have all these access mechanisms noted there in cppindia.co.in. Do visit. We organize sessions every alternate Saturday on topics as per community feedback and direction. And you will today receive a feedback form at the end. Please take a couple of minutes and provide your appreciation, constructive criticism for the session today, and also guidance on upcoming sessions that you would be interested in, and help us make them awesome. So let's get started with the presentation. Today we have with us Shilpa Dodeja. If you were here a couple of weeks ago in the previous session, she presented to us about unique pointers and how C++ is so excellent with zero overhead. You are able to get guarantees of good memory handling by using unique pointer, and just you pay for what you use. So let's get going with smart pointers with Shilpa Dodeja. Today, she's going to cover shared pointers and weak pointers. Shilpa, all yours.
Yeah. Thank you, Uncle. Let me just present my screen window. Is my screen visible? Okay, cool. So, hello everyone. Very good morning to all. So, this is the part 2 of the Smart Pointers session. In the previous session, we were able to look into as to what are smart pointers and why do we need them. So let me just give you a brief recap as to why do we need smart pointers, right? So smart pointers are needed so that the developers don't have to do the resource management manually. Why? Because if the onus or the responsibility is left onto the developers, then there are chances that our code might run into problems like the memory leak, the dangling pointers, or even worse, like the program crash. So one of the major and the immediate advantage of using a smart pointer is that unknowingly we as the developers would be writing a code that is free of memory leaks and dangling pointers and will at least save us the embarrassment of our program crashing at the client side. Now, obviously, it goes without saying, if we try hard enough, and since this is a C++ language, then you can obviously still bring back those issues even while using the smart pointers. So you just have to be a little bit careful as to how you initialize the smart pointer, and then uh, the smart pointer will take care of the rest of it. So the way the smart pointers helps us in writing this leak-free memory code is by ensuring that the objects are destroyed, or I can say the resources are released in the appropriate manner at the appropriate time. And the smart pointers do so by following a principle called RAII, which stands for Resource Acquisition is Initialization. So this principle basically states that if there is a resource that needs to be managed and this resource is bound to a particular class, like it has become a member of some class, and inside the constructor of that class, if we acquire that resource, and hence the name resource acquisition is initialization, and in the destructor of the class we free or release that resource, then we are following the principle called RAII. This, in practical terms, this principle basically assumes or gives the ownership of the heap allocated resource, or any resource for that matter, to a stack allocated object. So when the stack object goes out of scope, the corresponding or the underlying resource will also be destroyed or released, whatever the case is. So there are three smart pointers available in C++11 standard: unique pointer, the shared pointer, and the weak pointer. In our previous session, we were able to look into as to how we can use the unique pointers. And to give you just a quick recap, unique pointer will always have the exclusive ownership of the underlying object. That means it will be the only owner of that underlying resource. And when that unique pointer goes out of scope, the underlying resource will also be destroyed or released. Now, the beauty of the unique pointer is that it is as lightweight as a normal raw pointer. So there is no memory overhead as such. If you want to know more about the unique pointer, then you can obviously check the recording of our previous session on our YouTube channel. Are you able to see now this thing? The three types of smart pointers available?
Yes, yes.
Yeah.
Yeah.
Yes,
Okay,
good.
cool.
Thank you.
Sorry. So yeah, there are, as I was saying, there are three smart pointers available: the unique pointer, shared pointer, and the weak pointer. In this session, we would be talking more about the shared pointers and the weak pointers. So let's just jump right into the shared pointer session. So as the name suggests itself, the shared pointer will allow the shared ownership of a particular resource. That means two or more shared pointers can own a particular resource, like they will simultaneously manage the lifetime of that resource. Now if everyone is managing, let's say I have three shared pointers and everyone is managing that resource, wouldn't it be an undefined behavior if everyone would try to destroy the object whenever they go out of scope, right? So shared pointer does some kind of magic trick as to they ensure that the resource object will only be destroyed only once, even if there are three or four or how many shared pointers are pointing or managing that same resource. The way the shared pointer is able to manage this kind of count mechanism, this kind of trick, is by keeping a count of the owners of the resource that is being managed. So basically, the shared pointer is able to keep a track of the number of owners that they are managing a particular resource. And when the last owner goes out of scope, that is when the resource will actually be deleted, destroyed. So in this case, if I have three threads and each thread has a shared pointer within itself, and that shared pointer is managing that resource. So if even if the thread 1 goes out of scope and thread 2 and thread 3, like the shared pointer 2 and the shared pointer 3, are still managing that resource, so the resource won't be destroyed or deleted whenever the thread 1 exits. Similarly, when thread 2 exits, because thread 3 is still pointing to the resource, it won't free up the memory. Only when the thread 3 goes out of scope, that is when the resource will be actually deleted. Now, this mechanism that the C++ uses is called the reference count mechanism. Now, in order to understand how this actually works inside the shared pointer, we will have to look into the memory layout of the shared pointer. So this is how the memory layout of a shared pointer looks. A shared pointer will always have two pointers with itself. One pointer will, sorry, one pointer will point to the actual underlying resource, and another pointer will point to additional memory object. Now, this additional memory that is allocated on heap for the shared pointer is called the control block. So this is where the actual magic happens. This is where the housekeeping for the shared pointer is done. So this control block also has something called the reference count. So reference count is nothing but the number of owners that I was talking in the previous slide. So it will give you how many owners are managing this particular object. It also has something called the week count, and we will talk a bit about it in our later slides. So just leave it for now. We would in this particular shared pointer scenario, we only have to concentrate on this reference count. And this control block also has can also keep some other data, like if I have to provide some custom deleter to the shared pointer or etc. So the, by looking just at the memory layout of the shared pointer, two conclusions can be made. One, the shared pointer will always take twice the memory of the raw pointer, because it always contains two raw pointers within itself. And second, because it is keeping a count of something. That means whenever the shared pointer is copied or it is destroyed, this count will get affected, right? So there is definitely a performance overhead, there's definitely a memory overhead. So unless you have a very strong reason to use the shared pointer, you shouldn't really use it, right? Because it can get quite messy if you are using the shared pointers, as we will see in our later slides. So let me just give you a quick example as to how you can use a shared pointer and what happens to this control block at the runtime. So first of all, these shared pointers are nothing but the class templates. So if I want this shared pointer to manage a particular type of object, I will have to provide this type in its template parameter. Okay, so I have asked this shared pointer to manage this type of object, and then I would also have to pass the resource, already allocated resource, for it to manage. The shared pointer, or unique pointer for that matter, won't allocate the object, won't allocate the resource for you. They will only manage it for you. So here I have the entity object which I have allocated, and then I am asking my shared pointer sp1 to manage this object. So basically I am passing the address of this newly created entity object to sp1. Now when this sp1 object is created, you will see that a control block is also created on the heap. And then this one is nothing but the reference count. For simplicity, I'm just mentioning what is the reference count in the control block. So uh, uh, sp1 has two pointers. One will point to the entity object, another will point to the control block, and the control block will have the reference count as 1. Now if I have to check what is the reference count or how many owners are pointing or managing this particular object, I have a function called use count. So if I will just call the member function of the shared pointer, then it will give me the reference count. Now after this, I have created a nested block wherein I am copying the sp1, I mean copying my shared pointer to another shared pointer. So unlike unique pointers, which are not movable, shared pointers can be copied, because that's how the name derives, like I am allowed to share the ownership of the particular object. Now when I copy one shared pointer to another shared pointer, two things will happen. First of all, some memory will be allocated for it, and then the pointers will point to their respective locations, to the entity object and the control block, and then the reference count will also be incremented. So now if I am going to use count, then it will show me that there are two owners pointing to that particular or managing that particular object. Now I can also use it with sp2.useCount. It doesn't have to be sp1. Both will give me the same value because both are pointing to the same control block. This is actually where the magic happens, because both the shared pointers are pointing to the same control block, and control block has um, the number of owners. So it can pretty quickly detect whether I have to destroy the entity object or not. Now, when this nested block gets over, that means sp2 will go out of scope, right? So when sp2 will go out of scope, it will just delete itself. The entity object won't be deleted because sp1 is still pointing to it. Once and if I try to access or check what is the how many owners are pointing to it, then it will give me the value 1 as shown in the figure. Now, once this control block gets over, that is when actually the entity object and the control block as well will go out of scope. Okay, so this is a very pretty basic example as to how you can declare a shared pointer and how you can copy this. Um, it's pretty simple as you would have already done in C++. Now, because this is a shared pointer and it participates in the ownership of the underlying resource, so if I have to access that underlying resource, how do I do that? So for that, the shared pointer has already overloaded the arrow operator and the asterisk operators that are available with our normal pointers. So if I have a function called print of the entity object, then I can access via the pointer, or I can dereference this pointer and then access it via the dot operator. Then I can also check whether this shared pointer is actually pointing to some object or not by just checking whether it is null or not by using the null pointer. And if I want to access the raw pointer, then I can do so by using the get function. Now, when I am using the get function, the shared pointer won't release the ownership. It will just give me a raw pointer to it that yes, take it, and if you want to pass it to some functions, then you can do so. But the ownership still lies with the shared pointers. So don't mess with the raw pointers like by deleting the object and all that. So it will create undefined behavior in your program. And then we can also set the shared pointer to the null pointer. Basically, I am asking the shared pointer to not point to anything, to not manage any resource. Now, at this line, it is not guaranteed that the underlying resource will be deleted or destroyed. Why? Because it can happen that there are other shared pointers pointing to that same resource. Then in that case, obviously, underlying resource will not be deleted. But if this is the last owning pointer to that underlying resource, then yes, the reference count will go to 0, and that is when the object will be destroyed. And you can achieve the same functionality by calling the reset method of the shared pointer. Now, you have to be very careful about as to which method function you want to call. Like you want to access the member function of the underlying object, or you want to access the member function of the shared pointer itself. So if I have to access the member function of the shared object, like in case of get and reset, then I have to use the dot operator. And if I have to access the underlying object, that is I have to access the underlying object indirectly, then I have to use the normal arrow operator, or I would have to dereference it. So these are not the only operations available for the shared pointer, but these are pretty common ones which I have listed over here. Now, as I said before, that if you try hard enough, then you can obviously bring all those bugs that we had identified with raw pointers into our program code base, or if you want to irritate your colleague or anything. So yeah, but if you are the sole owner of that code base, then I would just say that try to avoid this kind of code. Um, so as we have seen previously, that if I have to initialize some shared pointer, then in that case I would have to pass in the entity object, as in the address of the entity object. So I can do so via the raw pointer as well, right? I have an entity object which is being pointed to by E. Then I pass this E to initialize the sp1. Will that work? Yes. Will it compile? Yes. Will it run? Yes. Everything is yes, but it will fail. But your program might crash. So sp1 is pointing So sp1 is being asked to manage this entity object, right? So it will point. Now since this is the first time that this object is being managed, then that means I would have to create, or the compiler would have to create the control block, and then it will have the reference count called 1. Now when I'm using the same raw pointer to initialize the sp2, then in that case again, the sp2, although sp2 will be pointing to the same entity object, it will be managing that object. In this case, a separate control block will be created for sp2. Why? Because when I was trying to initialize the sp2, it was as if this is a new entity object, because I am passing a memory address. So it will assume that, okay, this is a new object, I have to create a control block for it. So now two shared pointers are managing the same object as was the previous case, but in this case they both will assume the ownership, both will have the reference count as 1. Now whichever goes out of scope first, so let's say sp2 goes out of scope, so in that case the reference count will become 0, right? Now when this count will become 0, then entity object is also destroyed, because it is assuming it is the sole owner of that object. Now when we will try to when we will try to access the sp1, or when we will try to access this underlying object via the sp1, we will have something called the tangling pointer issue. So don't try to initialize the smart pointers with the raw pointers. Either directly, construct it over here, and then pass it to the constructor of the sp1, so that no other raw pointer can access the same memory location. Or you can also make use of the make shared functionality that is available in C++11 standard. So what this does is that it will create the entity object, it will create, and then it will ask the sp1 to manage this entity object. So in this case as well, we are just ensuring that the memory object is not being shared between the two smart pointers. Why? Just the memory address is not being shared. If it has been shared with sp3, now if I have to create, or if I have to copy this shared pointer to another shared pointer, then I would have to use the copy constructor. And in the copy constructor, we already have the mechanism that if a control block is already being allocated for a shared pointer, then sp2 will also, sp4 will also point to the same control block. So everything will work fine if you will just not initialize the smart pointers with the raw pointers. Just don't do it. Now this was about the smart pointers and what we should not do and how we can actually initialize it. There is something called custom deleters. That means if you want to specify some custom object, custom deleter for your object, then you can do so. So in case of unique pointers, I had to specify the type of the custom deleter over here. But in case of shared pointer, we do not have to specify the type. We just have to pass in over here. In this case, I am passing the lambda, but you can also pass the functor object or the function pointer. Now, custom deleters with shared pointer are very useful in C++11 and 14 standard. Why? Because there is no shared pointer available. There is no version of shared pointer available which will manage the array of objects. So if I want my shared pointer to manage this array of object, then I would have to provide a custom deleter wherein you would be deleting the array of objects by using the delete operator. In C++17 standard, this array version is already there. So like array version of shared pointer is available, so we don't have to use the custom deleter. But in case of C++11 or 14 standard, you would have to use it. There is no other way. And there is one more thing, is that we cannot use make shared with custom deleters. There is no such functionality available or the utility helper available. So in that case, you would have to use the new. So So basically, if you are using C++ 11, 14 standard, and if you have to manage the array of objects, then in that case, you would have to again introduce new and delete in your code base. But it would be pretty safe, I would say, if you are using the shared pointer. Now, this was all about how to use a shared pointer and what a shared pointer can do. But let me just give you a simple, quick example as to where you can use it. So let's say I have to write a doubly linked list data structure, right? So a linked list will have some kind of node. Now, in this case, in doubly linked list, uh, there's a next pointer and there's a previous pointer. So every node will have a next pointer and every node will have a previous pointer. So in this case, N2's next node is N3 and N2's previous node is N1, and they point via the pointers. So here I can use the shared pointer. I won't be able to use unique pointer over here because N2, sorry, because N2 is being pointed by two owners. So if I'm using unique pointer over here, it will give me a compiler error to me, right? So this is the perfect example as to where you can use the shared pointer. Now, this is just a very trivial example. So I have just created a doubly linked list. I have a head and the tail, which are also shared pointers because again, N1 will be pointed by the head as well as the next pointer of the N1, and same goes for N3. N3 will be pointed by N2 as well as the tail. So here as well, I have to use the shared pointer. And then I have a public method variable called the add node, and in this function, in the main function, I would just call the dll.add node. So I'm adding first node, second node, and third node. So this was just as to this was just the application of the shared pointer, like where you can use this. But when you will run this program, no, what will happen? The memory that has been allocated for all the nodes will not be deleted. Even though, so if I'm running this program and the main function executes and the program exits, the memory that is allocated for these three objects will not be freed or destroyed. Why? Any guesses? I'm using the shared pointers. It's correct. It will run. So there is no compiler as such, but there are still memory leaks despite using the smart pointers. So
Is it because everybody is holding on to everybody else?
yeah, yes, correct. So that is the reason. So uh, we 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 call this as cyclic references. So what are cyclic references? Let me just give you quick example as let me just explain you how cyclic references work, and then we can proceed on to the solution. Uh, yeah. So when this linked list goes out of scope, so that means head will not point anywhere because head will go out of scope. Tail will not point anywhere, tail will go out of scope. But N1 node is still being pointed by the N2 node. Why? Because in case of my node, I have kept both the next and the previous nodes as the shared pointers. So even though head goes out of scope, N2 is still pointing to N1. That means it is participating in the ownership. It is owning it. And similarly, N1 is also owning N2. Now N2 is also owning N3. So every other node is owning every other node in the system. So that is why memory leaks will happen, and this is where the weak pointer will come into picture. The weak pointer was introduced to break this cyclic reference that was created by the shared pointer, or that will be created by the shared pointer. So weak pointer is not a smart pointer as such, I would say, because in my previous case, what is happening is the shared pointers are owning each other. Like because there's so strong hold of ownership that no one is ready to release it. So I have to bring into the system which will not own that object but will still be able to point it. So weak pointer does not really participate in the ownership. When I say participate, that means it is not responsible for destroying or freeing or releasing that resource. Okay, so if I would change just the no, if I would just change one of the shared pointers to weak pointer, it can be anything. Like I have kept the shared pointer for next and the weak pointer for the previous. You can choose it the other way around. But in this case, what will happen when N2's previous pointer has a weak pointer to N1 node? Like N2 will just point to the N1 node, it will not own it. So when the doubly linked list data structure or the doubly linked list will go out of scope from the main. So head will go, right? Head will go out of scope. That means there is no ownership pointer attached to this N1 object. This is pointing to it, this is not owning it. So now no one is owning this N1 pointer. This will go out of scope, and obviously the underlying resource or the object or the data will also be deleted. Now, since this goes out of scope, N2 was N2 was already pointed by the N1. Now N1 has gone out of scope, N2 will also go out of scope, and so on and so forth until all the memory is released. So this this so in this case I have told you the actual reason as to why this weak pointer was used. I haven't really told you how to use them and how to initialize it, but I hope this was clear so that I can go ahead with the weak pointers. Um Anyone has any doubts in this cyclic reference or something, or should I explain it again if it was fast or something? Okay, so I will go ahead, right? So, as I said before, the weak pointer does not participate in the ownership. So that means it will not manage that object. So if a weak pointer is not managing an object, this will not, so this particular line will not make sense if it is not ready to manage. If the weak pointer is not ready to manage a particular object or a particular resource, then I can't ask it to manage it, right? So all these operations that are usually available for the unique pointer or the shared pointer are not available for the weak pointer, simply because it is not ready or it does not have the semantics to own or to participate in the lifetime management of the resource. Okay, so if I cannot ask it to manage some object, if since it is not managing any object, I cannot access the underlying resource. And similarly, I cannot also check whether it is pointing to some object or not. So what can I do with the weak pointer? Like if I have, in this case, if I have to traverse from N3 N2 N1 like in the reverse way, and the only way I can traverse is by weak pointer. So how can I access this particular N2 object via the weak pointer if all these operations are not available? So the only way you can access a weak pointer, like as in initialize the weak pointer, or uh, uh, um, access the underlying resource, is via the shared pointer. That's it. So if I have to initialize a weak pointer via a shared pointer, so if I have to initialize the weak pointer, then I have to do so via the shared pointer. So the shared pointer will manage this particular resource, and then if I will assign it to the weak pointer, internally weak pointer will point to the underlying resource, but it won't directly manage it. In our next slide, I will show you the memory layout of the weak pointer, wherein you will be able to see that weak pointer will be managing it, as in weak pointer will be pointing to it, but it won't manage it. So this is how you can initialize a weak pointer, and the only way to do so is by passing a shared pointer to it. There is no other constructor available apart from the default constructor. Now, if I have a weak pointer to it, right? Now, if I have to access the underlying object, then what should I do? Then again, you have to convert it back to the shared pointer. Uh, this is a pretty weird situation wherein, like, in order to use a weak pointer, I have to first provide a shared pointer, and then if I have to access it, then again I have to get the shared pointer. But this is the price that we pay if we want to break the cyclic reference in our code, and if we have to use shared pointers in our code. Now, in order to get the shared pointer, this is a pretty weird function called lock. It doesn't lock anything as such, it just returns a shared pointer to it. Now, if this shared pointer is available, like if the weak pointer is pointing to a still valid resource which is alive, then we will get a shared pointer, and then we can use it. If it returns an empty shared pointer, then in that case, that means that the weak pointer is not pointing to a valid resource, or I can say the weak pointer, the underlying resource that the weak pointer is pointing to, has expired. So we have another function utility called expired, which is just to check whether the pointer whether the weak pointer is pointing to a valid resource or not. Um, and there's another functionality which is available for every other smart pointer called the reset, wherein I would ask the weak pointer to just not point to anything. So I will tell you the as to why this shared pointer is coming as in between the weak pointer and the developers. So let's just have a look at it with the help of some example. Um, Uh, okay. Oh, sorry. There is some problem with my animation. So yeah, let's just go with it. So here I have created a weak pointer. Okay, I have not initialized it with anything over here. Then, in order to make this weak pointer point to a particular resource, okay, so I would have to create a shared pointer. Then, after that shared pointer is created, I'm just assigning the weak shared pointer to this weak pointer. Now, this entity object is created, and okay, there's sorry for the so yeah, so the shared pointer is copied to the weak pointer, and then if I would try to access, if I would try to check what is the use count or what is the reference count, that means how many owners are pointing to a particular resource, then in both the cases, SP1 as well as weak pointer, in both the cases I would be getting as 1. So remember in my previous slide, as I said, that control block holds another count called the weak count. So this weak count will come into picture when there are weak pointers pointing to a particular resource. So in this case, since there is one weak pointer pointing to this particular resource, then it will be incremented to 1. Now, also you can see that when I copied this shared pointer to the weak pointer, the memory layout of the weak pointer is exactly the same as the smart pointer, right? It also has two pointers. One will point to the entity object and one will point to the control object that was already allocated by the SP1. Okay, why? Because once this SP1 goes out of scope, okay, so that means the underlying object will go out of scope. Now, how would weak pointer know that the pointer it is holding is a dangling pointer? With the help of these reference counts. So if the reference count is 0, that means the weak pointer or the underlying object has expired. It is no longer alive. So I would get the SP1, or I would get the empty shared pointer. Okay, and when this sp1 goes out of scope, then in that case, if I would try to again check how many owners are pointing to it, I would get 0. And if at any time after this line I try to access the entity object, I won't be able to access it, and I won't get undefined behavior or dangling pointers in my program. So yeah, the only reason why weak pointer was introduced, so that we can resolve the cyclic references which was happening because of stronghold ownership of the objects. So the weak pointers are really, I haven't really personally used weak pointers as such, as I don't, my code base doesn't really use this. So this is just about how to use a weak pointers and in what case we should use the weak pointer. So this is just the last topic for the presentation, as in the smart pointer parameters. That means how is one supposed to pass these smart pointers? Like I have a smart pointer in my code base. How am I supposed to pass them? Should I pass it by value? Should I pass it by reference? Should I pass it by const reference? Or should I still use my old friends reference and my pointers? So let's have a look at every other case one by one. So let's start with pass by value. Okay, so looking at this function declaration, what does it mean? So when I'm passing a smart pointer by value, that means this particular function is participating in some kind of ownership, right? Now obviously in case of unique pointer, you cannot copy, you have to move it. So when this particular function will exit, and and this particular function will exit, so the scope of this particular unique pointer will also go away. That means the underlying resource will also go away, unless this function has copied or has moved to some other unique pointer. But looking just at the function declaration by value, by passing the smart pointers by value, that it means that this particular function is participating in some kind of ownership. Same goes for the shared pointer. In case of shared pointer, you can obviously copy it. In case of weak pointer, you can obviously copy it. But it has some kind of performance implications, right? It will take twice the memory of the raw pointer. It will uh, increment or decrement the reference count. So unless there is a real reason to copy your shared pointers or to make sure this function participates in the ownership, then only I would suggest pass these kind of smart pointers by value. The only use case wherein I can understand that this would make sense if you are trying to pass one message from one thread to another thread. So even if the first thread goes away or exits, the second thread would still be pointing to some valid object, and it can do its post processing, whatever he's supposed to do. So the other case, so if you just want to change this smart pointer or mutate or reset this smart pointer, then you can just pass it by reference, as we already do with our normal classes. So if I'm passing a unique pointer, shared pointer by value, then that means that this particular foo function can modify or can reset the unique pointer or the shared pointer. And if it has to do it, then it should. But if the sole reason to pass this pointers are to access the underlying object, then I would suggest it is better to pass them by reference or by pointers, as we will see in the next slide. So the smart pointers basically should always appear in the function signature if the function is actually modifying that particular smart pointer, or it will copy or move a particular smart pointer. Now you can obviously pass this smart pointers by const reference, but I haven't any found any use case for it as such, because when I'm passing a smart pointer by const reference, reference means I can mutate this object, but it is const reference, so I cannot mutate this unique pointer as such. So why will I pass, or why should I pass it by const reference? The only way I can understand it is, the only way if this kind of function appears in my code base, then that means this function is trying to access the underlying object, for which we already have our good old raw pointers and the references. So when I'm passing a reference, the or the pointers, like pointers aren't really bad as such. They are pretty useful. They have good advantages with them. But if I try to manage manually the resource management, then they can be pretty nasty. But otherwise, if you just have to use the object, you don't have to assume the ownership of the object, then just pass it by reference or the pointers. There is no need for passing the smart pointers by value or by reference. So yeah, this is it. The pass or return the smart pointers if the ownership needs to be assumed or released. Otherwise, just use the raw pointers or the references. To just summarize my previous session and this session, so we should not try to manually manage our resources, because they can bring a whole lot of issues with it, like memory leak, pointer issues, and whatnot. Now, when now if you're not using the raw pointers, what you should use, so you should always prefer the scoped lifetime objects, as in you should always use stack allocated, the stack memory, as much as possible, because there is zero overhead over it. That's available for free, and it can do the automatic memory management for you. So we shouldn't really move towards the heap objects or um any other such thing which might create a problem for our code base. So the always prefer the scoped lifetime as such. If somehow if I have to use the heap objects, or if I have to manage some resource, then from the three alternatives available, actually only from the two alternatives available, like the unique pointer and the shared pointer, I should always prefer the unique pointer, because they they don't have the performance overhead with it, they don't have the memory overhead with it. And only if you are if you understand that your objects will have to have shared ownership, they cannot have exclusive ownership by the unique pointer, then and only then use the shared pointer. And in case of shared pointer, I have not written over here, but if there are cyclic references, just use weak pointers, because even by using the smart pointers, you might end up having memory leaks in your code base. And the last point would be that you should always prefer to use make unique and make shared over the direct use of new, as if you can. Like in case of custom deleters, we cannot use them, so we have to use the new operator. But otherwise, I think make unique and make shared will uh, do the same thing for you, and in some cases, it might give you some performance boost as well. So yeah, that was my presentation. If you have any doubts as such, we have some time left.
Hi Shilpa,
Hi,
Shabnam
Shilpa.
this side.
Yeah, okay, sir.
Hi Shilpa,
Yeah,
Shabnam this side. Actually, I have one question. It's like when we are designing classes, so
yeah.
let us assume we have to create an object for database. So in that case,
Okay.
should we go for the references or shared pointer?
You can use references only if you are sure that there is some object available at the other side. And so the way, why do we use smart pointers or as in raw pointers? Because the end object can be nullable. Like might be you might not be able to initialize it in the constructor itself. The references are to be initialized in the constructor, otherwise you will get a compiler error.
Mm-hmm. Okay, thanks.
I have one question that how reference count is guarantee will be a thread safe. It
Yeah,
means
yeah,
that
yeah.
any mutants or atomic variable or some kind of thing.
Ha ha ha. So, okay, let me address that. Let me just go to this control block thing. So, whatever this reference, this control block does, so this is atomic. So whenever we are trying to assign a shared pointer from one shared pointer to another shared pointer, then in that case the control block is thread safe, as in it won't happen that the reference count will go some muddy, but the underlying entity object, um, it is not thread safe. You would have to make sure that the underlying resource is thread safe. It is the responsibility of the developer. So that is where atomic shared pointers and the atomic, I guess, weak pointer comes into picture. But I haven't been able to look into that, so I did not include this in my presentation.
Sure.
So basically, they help you to kind of, if I'm not wrong, to kind of access this underlying resource thread safe.
Yeah, Shilpa, I'll just add to Ram's point here. There are two reasons why you use a shared pointer. In your code base, it is so dynamic that you don't know which place the object is going out of scope, and you cannot clear out the object there. So you don't know. Maybe in a telecom like a situation, like either timeout happens, or the other party disconnects, or you get a network breakage, or you get some other event. So when you don't know where it'll get destroyed, it is best to manage such an object with shared pointer. This is still could still be in the single thread, but definitely the smart the shared pointer is ready for multi-threaded use with its control block fully thread safe. So all its control operations will be thread safe, and across threads will work absolutely fine using atomics and how Shilpa mentioned it.
Yeah.
Your
So,
object,
Uncle,
yeah, your object, you still have to make sure it is thread safe in its use. Yeah, Shilpa.
even I have one question over here. So in telecom
Yeah.
industry, like there is no performance implication as such. Like shared pointers obviously has it. So is it not tight, like latency wise or something in telecom industry?
Yes, it is. Yes.
Okay.
Okay, I guess we have a question also from Prashant on chat. Uh,
Okay.
Maybe I'll just read it. If we pass shared pointer by reference to another function, it will
Mm-hmm.
not increment the reference count,
Hmm.
right?
Yeah.
So I guess yes. The answer is yes. If yes, who will manage its lifetime if calling thread goes out of scope?
So if you're calling a function, the caller has called this foo function, right, in which you have passed the shared pointer reference. So unless this foo function executes completely, your thread won't be able to exit, if I am right. So in that case, your caller only will be managing the lifetime of the shared pointer.
Yes. Yeah, that seems to be the problem with the scenario which is given. Calling thread passes by reference a smart pointer, so there is no increment. Now, if the calling thread itself goes away, which means all references go out, lifetime extension will not happen for this object, which is managed via the smart pointer, via the shared pointer, and then it'll result in using memory, which is not really.
Yeah, I would like to add one more thing over here. Since you are passing the shared pointer by reference, then your function itself can change the shared pointer itself. So it might change the lifetime of the underlying resource. So if I just call the reset inside the foo function, then the underlying resource का lifetime gets gets the underlying resource gets destroyed, but the shared pointer का lifetime will be managed by a calling thread.
So good, nice and informative session. We do this once every 2 weeks, which is alternate Saturdays. Your feedback on the form on what you would like to cover next is most welcome. If you would like to present something, you have a certain expertise or have a great comfort with some part or whole of C++, please contact us. You can present here as well. So happy learning, guys. Thank you very much for joining today. Be smart.